So hello everyone, my name is Jürgen Pavel and I would like to present TokenTube, a solution for simplifying the use of full disk encryption for Linux. And this is part of the show and tell track for the Ubuntu Summit 1510. And my idea is to give you a run through a presentation that I've prepared. It includes some very short screenshots and demo parts and mostly covers the idea and some aspects of how it is implemented. So I'm going to switch to the presentation now. So the idea is to simplify the use of full disk encryption on Linux. And the issue here is that with the current full disk implementation that's based on the LUKS protocol/standard and the encrypt device mapper implementation at runtime, is that the LUKS has its own key management and thus a separate user or no user, but a separate password or passphrase or key to be used for the full disk encryption, whereas the login to the desktop runs through a PAM subsystem, which usually would be a local user and local password database on the system, or alternatively something like an LDAP or directory or any other implementation that's supported by PAM. So for an average user, and I'm assuming the use case of a laptop here, this would be for one, a password for unlocking the full disk encryption at boot time, and then the desktop login comes up and I have to then type in my username and my password. So the idea is that with TokenTube we will merge this together, because for most users it's actually a challenge to manage multiple passwords, and even though password changes are easily integrated into the desktop, the only real way to change your disk encryption password is via command line interface, and it requires root privileges. So all of this was something that I would like to change with TokenTube, and we're not considering other alternatives that exist or are coming up, like the encryption on the exe4 file system level. We'll just have to wait and see where that will be going. Also, something like eCryptFS that does an encryption above the file system layer, but more or less on the file system layer, we're not looking at right now, because it only protects a part of the file system, and with full disk encryption you protect pretty much everything. So the idea is to make it almost transparent to the user whether his password is used for desktop login or for unlocking the full disk encryption. So what are the requirements? There are essentially two basic requirements that say, one, the password policy must be enforceable if so desired or configured, which is obviously not yet covered with the LUKS passwords. And the other part is for enterprise environments. What if a user forget their password and would like to call a help desk, whatever, and get a recovery password? That's something that I define as a requirement for TokenTube, that this process must not be replayable, so attack against a replay attack. And the idea here is that it's safe against single-stage replay attack, so someone that only eavesdrop on the help desk call or whatever, but not someone that actually manipulates the system or whatever. The constraints for one, security. The idea is to implement something that has a reviewed crypto and also a security audit on the implementation itself, on the source code. happened and is obviously ongoing as the implementation continues. For compliance aspects, and obviously that's an enterprise aspect, the cryptographic primitives must be configurable. So if some organization or maybe even some individual user doesn't like, for example, AES, then they must have an option of choosing another crypto cipher or a hash or whatever. Also, there has to be something that documents whatever happened, and that's the audit trail. Usability, that's the main idea, is to make this better than the current setup and essentially make it so that the user doesn't even realize what his username and passwords are used for when he starts the system or when he logs into the desktop. It should all just be merged together. The last part, and that's pretty much one aspect that's somewhat of a to-do still on my project, is useful documentation. So anything from user documentation, enterprise administration documentation, documentation for programmers that would like to extend or fork the software, package maintainers. So the idea is to provide useful documentation. I've started, but that's pretty much the last major to do on my project, to do this with TokenTube. So on the abstract side, what is requirement? What are the required software components? First off, we need a pre-boot authentication UI that essentially asks the user for his username and for his password. And these are pretty much distribution specific because of the different pre-boot environment UIs that exist. So that may be something where more work needs to be done to cover more pre-boot environment UIs. What's implemented is text mode and the Plymouth graphic stack. And obviously this is for starting the system. This is where the full-disk encryption gets unlocked when the user provides a valid username and password. Second, the idea is that we need a system authentication component that's essentially a PAM module that's generic, so except for packaging, that's generic, that can be used on pretty much every distribution. And this is necessary to have a hook in the PAM system that recognizes whenever a user changes his password, so the password can be updated to be used for the pre-boot authentication. For maintenance, a command line interface exists that's actually Python based, so that's also distribution agnostic, and manual tasks like creating a user, deleting a user, modifying a user can be invoked from this. And all of these components themselves rely on libTokenTube. That's a library that pretty much contains the entire logic. From a cryptographic viewpoint, the system abstracts the looks keys to the users. So one looks key is used in one looks key slot as the TokenTube key, and every user that's enrolled to the system encrypts this key with their password. So I started the project in 2009, and as you can see on this commit timeline, that's pretty much sporadic development, and pretty much that covers, or the development happened during conferences that I attended. So if you look at the time when the commits happened and look at the conference schedule, you can somewhat infer at what kind of security conferences I was. That's not to say that development isn't ongoing or independable. I've always continued with this, and as I got to the 1.0 release, which was in January 2015, since then, and with going on to getting closer to this this milestone, I got into pretty much continuously developing this software. So my idea is to have it pretty much complete at some point in 2015, so that feature completeness is given, and thus I would like to then only take care of changes like security updates or any other yet unforeseen feature requests. So here's the first demo. This is the pre-boot environment. That's actually what you just saw was the pre-boot authentication component that replaces the already existing password querying component that is implemented with Ubuntu if you have full-disk-encryption active. And the interesting part here is that it asks for the username, and that username, that user password, is actually the very username, user password that I used to log on to the system that I recorded this screencast on. So this is using my user credentials, and essentially to the user, this behaves as if it was a desktop login. He types in his own username, his own password that he knows from his system. The next demo is actually what the password was forgotten aspect. So what happens is you just leave the fields blank. The system will then show you a challenge code. This challenge code is generated randomly each time that this process is invoked, and it's the OTP process, so that the one-time password process. This challenge is in the next step combined with a response. This response is obviously not provided or calculated on the system that is protected by the full-disk encryption, but rather on a third system. And the idea here is that you have some sort of help desk that you can call, and what they will do once they receive your call and authenticate you as the person that's legitimate to start the system to unlock the full-disk encryption. We'll see that next. So this is a web interface, and essentially there's one system in here. I now clicked on generate response code. So the challenge code that was shown in the previous mask on the system to be booted has to be typed in this mask. And with generate response, the response code is calculated on the system, on the server side, and has then be told to the user so that he can type in this response code into the pre-boot authentication component, so that the system can be started in one time, and from then on the user password reset process has to be conducted. So this response code is now typed in by the user into the field, and once he typed that in, this challenge and response code combined will lead to a valid key that can unlock the LUKS encryption, the full-disk encryption. So this is essentially was a demo. The implementation for that one-time password support process is not complete, as you may guess from the just the UI of the website that you just saw in the second demo. So that's work to be completed. I'll get into that a little bit later. So looking back, I already said release 1.0 was January. With the release 1.0, I'm at a point with the project that has a stable code base, stable API. so the library, etc., and the data format that stores the user's credentials that wrap the key are stable. With the 1.0 release, I migrated the sources from SourceForge to GitHub, and release 1.0 has roughly 9,000 lines of code, which equates to 23 person months of effort according to the Kokomo standard. I have a PPA that, as of today, is not current, but I will shortly upload updated packages for Ubuntu to it, so this can be tried out pretty easily. One thing that was a major task during the last part of the development leading up to 1.0 was unit tests and static code analysis. Essentially, there's no open issues, and that pretty much assures that the code is security reviewed. My next milestone will be release 1.1 this month. So the documentation will be basic guidelines and main pages, etc. And the challenge response system that I've just shown in the demo is essentially at a proof of concept stage, and this will be completed into essentially a enterprise ready level later on this year, which will be what's on the roadmap for release 1.2 that I'm aiming for August, because again, then there's another conference that I will attend, and that's always a good time for me to do a lot of work on this project. So internally, the web application that was just shown will have a SMTP and a REST interface that can be used to create new, or to provide the new cryptographic material that's necessary to calculate the valid response, given that someone has a challenge string. And also another aspect will be that the usability and manageability aspects of the pre-boot authentication component will be improved, so that something like a help page or something like that can be available to the user. Maybe even something like a help desk hotline that can be provided to the user if he does choose to run through the OTP process. For Java, I have two aspects on my to-do list. One is a plugin. So essentially this is the ability to use Java components from TokenTube, and the other part, bindings, is that from a Java program that you can invoke TokenTube operations. The single sign-on feature, I have to step back a little, and configurable option for TokenTube password into the pre-boot authentication is that for exactly that system startup, that the username and password can be remembered by the system until the desktop login appears. And if you have configured this, then the username and password will be attempted to do a login on the desktop. And if that's successful, obviously that depends on the authentication data in the authentication backend of the user subsystem. That works or may not work. For example, the system may boot with a username and password, but the login may not work because the user in the LDAP database has been logged. What has been implemented is the single sign-on for LightVM, so the standard Ubuntu login manager, and what's on the to-do list for release 1.2 is for the SSDM window manager. So that's the window manager of KDA5 and for LXDE. so that even for the other flavors of Ubuntu that this single sign-on can be used if so desired by the user. For 1.3 December, I would like to have other backends for the OTPs, so for calculating the valid response, so that maybe users can have this backend maybe on their smartphone. So once they see the challenge string, they type in on their phone the challenge string and get a response string in response that they then type into the PVA and thus start the system. Essentially, this is a one-time password, a generic variation of a one-time password concept for booting the system, for unlocking the full-disk encryption. And another option might be, instead of calling a help desk, to have some sort of SMS or a dial code based backend. So essentially replacing the web UI front end through some sort of automation system, and thus not having the need to rely on the person to actually type in the challenge string to read out the response string, but to have it automated through maybe some telephony system like Asterisk or something else. So past that, I don't have any more features that I would like to implement with TokenTube. From at this time, I would like to consider it feature complete at that point. And as I said earlier, I will always handle security or other updates as necessary. So maybe something changes with the login managers that needs to be adapted in the TokenTube component. I will always maintain that, but I would like to make the system feature complete by the end of this year. For security vulnerabilities, because I work in the security field, I happily accept any reports about security vulnerabilities. I will address them, and I will make this a personally financed bug bounty. So if you find any security vulnerabilities in TokenTube, report them to me, and I will see how much this vulnerability would be worth in money or whatever else. That's a personal bug bounty, so I don't have any rules or anything. It's at my sole discretion to decide that, but my intention is that this is vulnerability free, and we'll see if that holds true or not. I don't have any commercial intentions, so obviously for personal use, for making the use of full-disk encryption easier on Ubuntu systems on just a standalone laptop, that's not an issue. But as you might imagine, with the help desk feature, companies would be interested in this. I don't have any intention of providing any sort of support or services. I would be hoping that if this gets integrated into Ubuntu, then that will become part of the standard Ubuntu support package that's available for companies. And obviously that's the reason why I need to provide useful documentation. So this is a personal project, so obviously I'm eager to continue with this, but this is always synced to my work schedule. And again, if there's a critical security vulnerability or anything, I will make sure that this will be handled in a really, really short time. But if there's a feature request for some feature X that even I consider to be useful, it might take weeks, months, whatever, before this is implemented. That's obviously some sort of balance that I have to make between my personal life and this project. So that's the generic part of the presentation. Now we get to some technical aspects, and I would like to start with a visualization of what's going on here. That's really, really a basic view of it. The idea is that this represents the drive that's encrypted. So you have you always have an unencrypted boot partition. That's the part that's in green at the bottom, and then you have the encrypted rest of the drive. That's the part in red. So the red part here, the red signalizes that some information is encrypted. So within the boot partition, obviously somewhere needs to be the information that once a user provides their username and password can be used to unlock the cryptographic key. So the idea is that within this boot partition, in a subdirectory, each user has its own file, and if a username is when the username is provided, that's used to look up this file. The file name is essentially a hash of the username, and in that file is the cryptographic information that, provided the correct password, will lead to the looks key that is stored in the looks header. That's part of the encrypted partition. But when that is unlocked, then essentially the system is available at runtime. So once the system is started, etc., maybe the user would like to change their password. So maybe if they do it from a command line, they use the password command. Any other subsystem like the graphical way of changing your password is also supported. Anything that plugs into PAM is supported, and by that mean a PAM module is implemented, the PAM TokenTube. Essentially, if you change your password, this module updates the user files within the boot partition. So even after a password change, you can still successfully boot the system using your username and then current password. So that's the basic idea. The demo, and I'm sorry for the poor quality here, but as you can see on this system now under boot TokenTube user, there are no files. So essentially TokenTube is installed but has not any users active. So the command is the TokenTube user create, provide the username Jürgen, have to provide a password. If that password matches my current login password, then the user is created. Here now I have the hash of Jürgen, and essentially we now find a file with that hash value as its file name, and within that file is now the information that's necessary to actually convert the password that the user provides into the looks key that unlocks the system at boot time. And we will get into the cryptographic information that's provided here in just a second. Essentially, this is a self-contained data file that all it needs is the correct password to unlock the system. So obviously, a system like this needs some configuration. Under etc TokenTube, there's the main configuration file, the tokentube.conf. This has a couple of sections. The crypto section allows you to actually configure any cryptographic primitives that are used. So the cipher to be used, the hashing function, the key derivative function to be used, and this is to allow users to change the cryptographic primitives if necessary. So if some vulnerability, some critical cryptographic vulnerability becomes known in, let's say, AES 128, but remains unaffected in AES 256, then the admin can change this the encryption cipher here from AES 128 to AES 256, and with the next time the users are actually using the system, the cryptographic primitives are exchanged at runtime for the encryption process. The storage section essentially lists the file permissions that are applied to the files under /boot TokenTube, /user or /OTP, etc. The section user allows you to define enrollment filters. So let's say you have a system that's used by multiple people, and you would like for all the users that use the system in the group laptop users, for example, to be automatically enrolled into TokenTube. So when they log in, the cryptographic information is calculated, and the file is created under /boot TokenTube user directory. The OTP section configures the challenge response subsystem, and we'll get into this a little bit later on. The basic idea is that the strength, the cryptographic strength, can be configured. So essentially, how long or how short should the challenge response strength be? Runtime section essentially has logging configuration, log level for syslog, and for debugging debug level configuration, and then section plugins exist, and this is a subsystem that allows the behavior of TokenTube to be essentially fully configurable. So one idea might be to not store the cryptographic information for users in the boot partition, but rather in a some sort of directory. Then another plugin would allow you to change this behavior. And the configuration for any plugins would be in etc TokenTube conf plugin, and then the plugin name essentially. So starting with etc TokenTube, tokentube.conf, you will find references to any used configuration files. As we saw on the demo just a minute ago, the command line interface, TokenTube, there are commands to create a user. Username and password can be provided as parameters on the command line. If they're not provided, they will be asked interactively. And obviously, providing the password as a parameter on the command line is not suggested because that can be observed by other users on the system. The basic idea is that this command line interface should never really ever be used, because everything that needs to happen can happen through the user interface of choice by the user, for example, through the password change dialog in Ubuntu, in GNOME, or Unity, or wherever. So from the demo that showed the contents of one of the user files, the idea is that we have this information in each of these files. We have an API information to show with what version of TokenTube this data was generated. That's a mandatory field for any future TokenTube or plugin implementations. And the actual data that makes out the cryptographic part is in the user. So you have the cipher, and that cipher is obviously taken from the central configuration file, and the same goes for the hash function, the key derivative function, the number of iterations, and that's essentially how the central configuration, which is stored in the etc directory, which is or should be part of the encrypted partition. So that's not available at boot time. So the idea is to replicate this information into the user record. So it's a standalone data set that doesn't depend on anything else. The key item itself is actually the looks key that is encrypted using the user password And the username itself is actually also relevant because it is used as a initialization vector for the cryptographic operation. The verifier is actually more or less a helper data because it verifies whether the key was actually correctly decrypted, so that the password validation can occur without actually applying the cryptographic key that was deciphered. So the cryptographic part is essentially you have the data, and the data is in that part the actual looks key, and this is again one key for all users on that particular system. The key is a derived key from the username and the password using the hash function that's configured. And the initialization vector is also a derived value using, again, the hash function to be employed and the password and the username. So these are, the order is replaced. Essentially, they depend on the same input values, namely the username and the password. The verifier is a hash of, again, the key derivative function. The result, the input is the hash of the password and the hash of the username. So the input values are the same, the cryptographic operations are different, and that leads to a cryptographically different result. For the challenge response or the one-time password system, again, there's a commands on the TokenTube command line interface. Essentially here, the identifier takes part of the username. So you might have an identifier, a one-time password that might be identified by the host name, or maybe you have different one-time password cryptographic sets for each user. The idea is to be generic depending on the context where it should be deployed. So essentially the challenge, the OTP challenge, is what we saw during the demo. That's the challenge string. It generates a random challenge string. In the demo, we saw how the response string was calculated on the web interface. This command line interface essentially does the same thing. You need to provide the challenge to it. It will return then the response. And using the OTP apply command, you can actually use the challenge and the response to unlock the cryptographic key. That's obviously not too useful to the average user, but more of a development feature, a test feature, or maybe some sort of administrative scripting feature. The idea is to be just complete and not dependable on just a single implementation like the web application. So OTP records, these data are stored in standard in the OTP subdirectory on the boot partition, and you have a similar setup. So you have the API information as a mandatory field, and then the hash bits and data, and these data items will get into the next page, how their cryptographic setup is. And here we have a differentiation between the client, that's the system to be booted, to be unlocked with the full-disk encryption, and the server, which must not necessarily be a server, but in the demo with the web application, it was a server. It must essentially have the information to calculate a valid response. So essentially the ID of the system, the OTP hash, the bits, and an iteration count and the looks key itself. Why that's relevant is what we'll get into the next slide. So this is a little bit more complicated. The basic idea is that for each time a challenge response is calculated, then the challenge response database is iterated one more loop account, so that a single stage replay attack is not possible. The 3 steps involved are shown on the bottom. So the client generates a random challenge, and the server calculates the response, which is an XOR of the challenge, the looks key, and the OTP data that's present on the server and the client. And then the response must be typed into the client, and the XOR of the challenge, the response, and the OTP data will then reveal the actual looks key. And at that point, the OTP data is iterated through one more hash iteration. The OTP data is essentially a state that protects against replay attacks. The OTP handshake itself, we saw it in the demo, has a certain text structure to it. The idea is that the length of the challenge response handshake can be configured. So if you have rather low security requirements, 64 bits might be reasonable in order to yield a shorter challenge response string. Or if you have high security demand, then the challenge response strings will in turn be longer. So it'll be a little bit less convenient to the user, but it'll in turn result in a higher security level. Both the challenge and the response string have essentially two parts to it. One is always a 4-character field at the beginning, and that's sort of a checksum to make sure that both server and client are in the same state. And then you have depending on how many bits you have configured, you have next group of characters that essentially make up the handshake or make up the challenge for the challenge. So that's just randomness. And it's important that this does not have any strong entropy requirements. So entropy is not cryptographically relevant here. That's important because during a pre-boot authentication stage, it can be with fairly strong certainty be assumed that the system does not yet have good entropy. So that's pretty much important for a cryptographic viewpoint. The response, again, has at first a checksum to make sure that, again, the client and server are on the same state, and then the response, and that's, again, the challenge XORed with the state and the key. And that's essentially it for the OTP process. Next up is plugins. The lib TokenTube contains as a library pretty much all the functionality except for the actual implementation. So one part of the implementation might be storing the files in the /boot/TokenTube/user subdirectory. That can be changed by using a different plugin. It's important to have these plugins because that allows for context-dependent flexibility. Some of the plugins that are already implemented are Python and Lua plugins, so that this behavior can be implemented in scripts. There's an exec plugin, which essentially just invokes a binary, so any binary can be used. There's the help desk plugin, and that's actually the plugin that when a new OTP record is created for a challenge response handling, somehow this information has to be provided or sent to the server side that then calculates the response string. And one transport channel is using SMTP, so the data is PGP encrypted, and the other part that's not yet implemented will be a REST interface, then obviously using transport security like TLS. For development purposes, the test plugin is essential because it implements exactly the storage aspects, and it implements not storing the data in /boot, but rather in a local directory. So unit tests, all unit tests, etc., use this plugin because only with that unit test can effectively be implemented. The test plugin itself should not have any relevance for any real-life deployments of TokenTube. It's a test plugin, yeah. Extensions are bindings, so allowing from any other runtime like Python to use the functionality of TokenTube, and the command line interface is actually implemented in Python. So the TokenTube command line interface uses the Python extension or Python binding as the common wording would be, and so essentially it loads the libTokenTube, which in turn loads plugins to actually execute the requested actions on the configured system. And here a Java extension is on the roadmap, as I mentioned earlier. Some further aspects that we could discuss but won't be able to go into now because time's almost up are distribution packages. I already have a Ubuntu packages that are available in the PPA I mentioned earlier. And again, the warning here that as of today, the packages in that PPA aren't current. I will create new packages shortly and upload them to this PPA. We could go into more details of the help desk subsystem, the single sign-on, so the part where if you have configured this, the system remembers what username and what password you typed in the PBA, how that information is protected against manipulation or observation by any malicious software on the system. That's something that I've put a lot of effort in to make sure that only the application that actually will conduct the login on the window manager is able to get that information, and not any like malicious other software. Development internal. So what's the structure of the source code? What are differences, plugins, extensions, the plugin API, etc., etc. We'll just skip over that. What's interesting is the default implementation, specifically the calculation of the cryptographic information as detailed earlier, and the implementation of storing this data in the subdirectories in the boot partition. All that is implemented in a plugin that I call default. And this plugin is actually embedded in the libTokenTube, so it's not dependent on any other library. For plugins, the default plugin is something that's just there, but it is actually implemented as a plugin internal. So I'm pretty much perfectly in time. I have 6 minutes for questions, and please do ask questions. I just checked, there are no questions as of yet in the IRC channel. And also there are now no further users in the IRC channel, so That must pretty much mean that either I did a pretty good job at presenting all this information, or I've done a pretty bad job, and I hope that it was understandable for you. And I would really like for this for TokenTube to be part of the Ubuntu distribution, and also obviously I would like to get this integrated in other distributions, just to make life easier for everybody regarding the use of full-disk encryption. So thank you for watching, and actually let me just switch back. So thank you for watching this, whether it was live during the Ubuntu Summit or whether it will be later on the Ubuntu channel. And I'm sure you will find my contact information, even though I haven't provided it in this presentation. If not, it's jürgen@pavel.net, so my first name and last name. But it's also available on in some repo file on GitHub. So I'd be happy to get contacted about TokenTube itself, or getting TokenTube integrated in distributions, especially Ubuntu. So thank you and goodbye.